In this video, I'm going to continue section 12.5, which is about equations of lines and planes in R3. And then this video is more like a supplementary video to the previous one. And there, I covered an equation of line. So let's remember, given the line L, which goes through the point x0, y0, z0 with a direction vector ABC, what does that mean? This means pictorially, point P naught is here, and then the direction vector is a vector that represents the direction of the line, like this. Okay. And then there are two different ways of expressing an equation of the line. One is called the parametric equation, which is given in this way. Basically, you list x0, y0, z0 as the constant terms, and then ABC, the components coming from the direction vector, are in front of the parameter t, and t is called the parameter. And one way to think about it is to consider t as a time, variable for time, and at each time t, the position of the particle on L is given by xyz, which is given in this way. And indeed, if t is equal to 0, those terms go away, so you get x0, y0, z0. That's p0. So p0 can be thought of as the initial point. So that's parametric equation. Or by eliminating the variable t from those three, you can rewrite it as this, and this is called the symmetric equation. Okay, and then essentially, depending on the problem, one expression is easier to deal with than the other. But in principle, you are supposed to be able to solve any problem in whichever notation you use. But anyhow, then now, first let's do this exercise. Find a symmetric equation. Equation of the line through the point 1, 3, -5 with a direction vector -2, 0, 7. Okay, first, let's do the parametric equation. So the problem is asking you to find a symmetric equation, so you have to do this. But before doing this, let's just do this. The parametric equation is given by what? X is equal to x0. x0 is here, plus -2t, and y is equal to y0. y0 is here, plus 0t, and then z is equal to -5 plus 7t. Or you may just simplify it as x is equal to 1 minus 2t, y is equal to 0, and z is equal to -5 plus 7t. Okay, that's fine. But then now, what about the symmetric equation? Well, as you could see, you just subtract the coordinates of the point the line goes through, and then on the denominators, what you see is ABC. They come from the direction vector. So let's just list those numbers as this. So in this case, symmetric equation is written as x minus x0, that's 1, divided by -2, and y minus 3 divided by 0. That's not good. And by the way, z term is 7. Well, what should we do? Well, this doesn't make sense. But this makes sense. So if this happens, namely, if you want to find a symmetric equation, but one of the denominator is 0, if this happens, what you have to write is this. Oh, this is 3, sorry. Just write down this, in this case, z plus 5 divided by 7. And then just separate this as coming from y is equal to 3. Okay, what this means is that no matter what t is, no matter what the time t is, since you multiply 0, y is 3. So that means y is always 3. So you could write symmetric equation in this way. So that's the way to express the symmetric equation when one of the denominator is 0. Okay, so that's one remark about the symmetric equation. Okay, and there's one more thing we have to cover in this video. That's about the what's called skew lines. I have to introduce the concept of skew lines. All right. Let's note the following. Suppose you have two lines. Two lines in R3 XYZ space. Then those are parallel to each other. Each other. If and only if, what? Well, of course, their direction vectors are equal. Well, direction vectors are not equal. Their direction vectors are actually parallel to each other. Well, that's fine. Pictorially, suppose you have line L, and then suppose you have another line L1. I mean, suppose you have a line L1, and then you have another line L2. And the direction vector for L1 is, let's say, V1. And the direction vector of L2 could be V2. Those two vectors don't have to be equal, but those two vectors are parallel to each other, then two lines are parallel to each other. That's fine. And if this happens, of course, L1 and L2 do not intersect. Now, but let's say in R2 on the xy plane, if you have two lines, either line 1 and line 2 are parallel to each other, like this, or if they are not parallel, those two lines always intersect. So in R2, two lines are either parallel to each other or otherwise they intersect at some point, because the lines always go forever. So eventually in R2, if you do not have parallel lines, then those two lines have to intersect. Okay, that's fine. But in R3, that's not always the case. Namely, even if you have two lines that are not parallel to each other, it might happen that they do not intersect. And those two lines are called skew lines. If two lines in R3 are not parallel, but still do not intersect. Then those two are called skew lines. Skew lines. Like how? Well, it's like this. It's in 3 dimension. So if you have line 1, and even though line 2 is not parallel, it might go underneath L1, like situation like this. It's a bit hard to write down a 3-dimensional picture, but it could happen like this. So in that case, those 2 lines are not parallel to each other, but still they do not intersect. So those 2 lines are called skew lines. Then, excuse me. All right, then, to see this more algebraically, let's consider this example. Consider the 2 lines. 2 lines. L1 and L2 given by L1 is x is equal to 1 plus t, y is negative 2 plus 3t, and z is equal to 4 minus t. And L2 is given by x is equal to 2s, y is equal to 3 plus s, z is equal to minus 3 plus 4s. Since we are dealing with 2 different lines with parametric equations, we use different letters for the parameters for the second line. And by the way, this means if t is equal to 0, the line goes through 1, negative 2, 4. So that's the initial point. And then the direction vector of this line is 1, 3, negative 1. And similarly, if s is equal to 0, this goes through, actually, what's hidden here is, of course, 0 plus is hidden here. So 0, 3, negative 3, that's the initial point of this line. And then the direction vector for this line is 2, 1, 4. Okay, so the direction vectors are 1, 3, negative 1, and 2, 1, 4. Okay. And then now, by looking at the direction vectors, you could tell that they are not parallel. Not parallel to each other. Why? Well, remember 2 vectors are parallel to each other if one is a scalar multiple of the other. So suppose you have vector v1 and vector v2. In order for those 2 vectors to be parallel to each other, one vector has to be obtained by multiplying a scalar to the other. That's a condition for 2 vectors to be parallel. But if you look at this, if you look at the first component, it's 1, and then this component is 2. So that means in order to obtain this by multiplying some scalar to this, or in order to obtain this to multiply by some scalar to this, this has to be 2 times this, right? 2 times 1, 3, negative 1. Okay. But that's 2, 6, negative 2. So that's not equal to this one. So those two are not equal. So that's why you could tell that those two are not parallel to each other. Two vectors are parallel to each other if and only if one is a scalar multiple of the other. Okay, so they are not parallel. That's fine. But then now the question is this. Then now, are they skew lines? Skew lines? Well, how are we going to do this? Well, if they are not skew lines, they have to intersect. Okay, so if they are not skew lines, namely if they intersect at some point, then for some choice of T and S, we must have, well, it has to be the case that x is x, namely those two are equal. And then y is y, those two have to be equal, negative 2 plus 3t is equal to 3 plus s. And then finally, 4 minus t is equal to negative 3 plus 4s. Okay, so therefore, we have to be able to solve this system of equations with three equations. Then now, by looking at the first two, you can actually solve this. I'm not going to do the detailed calculation for this. This is the exercise. You could actually solve this as 11 over 5 for t and s 8 over 5. But then now, in order for those to be the solution for this system of three equations, you still have to satisfy this with the same s and t, meaning that those two have to be able to plug in to this, and we still get the same equality. Then now, if you look at the right-hand side, or left-hand side, sorry, this gives you, if t is equal to 11 over 5, 4 minus 11 over 5. And then that is computed as 9 over 5. On the other hand, if you look at the right-hand side, and with s 8 over 5, what you get is negative 3 plus 4 times 8 over 5. And that gives you 17 over 5. And those are not equal. Those two are not equal. So what does this mean? This means it's called nonsense. Or another name is for another name for this is contradiction. In other words, in no way can you solve this system equations for s and t. So this means that there are no such t and s. Such t and s means t and s that satisfy all those three at the same time. So therefore, they are skew lines. Because there is no common intersections of those two lines, meaning there is no parameters t and s that satisfy those three at the same time. Okay, so that's the answer. All right, so that's the end of this video. And in the next video, I'm going to talk about planes.